Hi everyone, welcome to my channel Pure Biology, and today I come with another video. That is, it is the topic related to Hardy-Weinberg, how the Hardy-Weinberg affects on the inbreeding process. You all know what is inbreeding. Inbreeding means when the breeding is occurring within the species of same individual. Okay, that means when the species remain in an area, then but this species is also present in another area, but inbreeding is occurring only only the individuals that present in the particular area, not with the other area or with the other areas same species. Okay, so this is called the inbreeding. So what is happening here? That means Hardy-Weinberg process, how affect on this inbreeding is that when two heterozygote individuals met the expected genotype frequencies among the progeny are half heterozygous genotypes and 1/4 of each homozygous genotype. And in every generation, the heterozygote frequency declines by half, while 1/4 of heterozygote frequency is added to the frequency of each homozygote. So actually, this is the example. What is saying that? That is saying if inbreeding is occurring, in that situation, the first generation where half heterozygous produced and 1/4 of homozygous, each homozygous genotype produced. But after every completion of every generation, what will happen? The heterozygote frequency that declines by half, clear? And 1/4 of heterozygote frequency is added to the frequency of each homozygote. That is half of the heterozygote after completion of each generation, or you can say in the next generation, after every generation, the half of the heterozygote, half frequency of the heterozygote, that will decline. And what will happen to the homozygote? That 1/4 of the homozygote, not saying that, 1/4 of the heterozygote that are added to the both homozygotes. So what is occurring here? Suppose this is an example. So in the first generation, the homozygotes, this will be 0.25, 0.50 heterozygote and 0.25 homozygote. Suppose, and these are the allele, capital A and the small a. So suppose this is 1/4, this is half, and this is 1/4. Clear? First we have to understand what is the actual happening, or what event is actually happening in the heterozygotes. That means you can see that half of this, the frequency is the half of the total frequencies. Clear? And this is the 1/4 of the total frequency. Suppose this is the total frequency is 1. So in that situation, half is the total heterozygote, 1/4 is the homozygote, and 1/4 is the homozygote. This is suppose A. This is suppose small a. This is capital A. This is the small a. Clear? So in the next generation, that means the F2 generation, what is happening here? First, you can just observe the heterozygosity. First generation, the value was 0.50. In the second generation, the value becomes 0.25, and 0.25 is the half of 0.50. Okay. 0.50. The half of 0.50 is that 0.25. Okay. That means this is the half of the total frequency 1. and this is the 1/4 of the total frequency. Clear? In the next step you can see that 0.06, that means 0.25 into 1/4. So this will be 1/8. Okay, so that means you can see the heterozygote frequency becomes completely declines up to 1/8 of the total one frequency, up to 1/8 after the third generation. Clear? But in case of homozygote, what actually happening here? In the first case, that is 0.25. Okay, and in the second case 0.37. So what is saying there, that in every generation the heterozygote frequency declines by half. That is totally proved here, and 1/4 of the heterozygote frequency is added to the homozygote frequency. Clear? So first we have to calculate the 1/4 of the heterozygote frequency is what? 0.50 into 1/4. Cancelling. So this is 1/8. So you can just divide 1. This will be 0.1. Approx 0.12. Okay. So what was saying that 1/4 of the heterozygote frequency is added. The value now 0.12, and in the first generation the value was 0.25. Now you can add 0.25 and 12, that will be 0.37. Okay, so here 1/4 of this is added here. Same case happening here also. In the third generation, what will happen? Now 0.37, its 1/4 is what? .09. So 0.37 and 0.9. Once again, I have to check this value first of all. Okay, I was wrong that I just calculated with this value. No, this is not the actual value. The actual value is homozygote or the homozygous. That means homozygous frequency is why it is important. That means that it's saying that its 1/4, its half, that is added here. That means this line is saying that what? 1/4 of the heterozygote frequency is added to this. That means not its 1/4 frequency, its 1/4 frequency. Okay. So I had a mistake. That now you calculate 0.25 into 1/4, because in first case 0.50 into half, into 1/4. In the second step also 0.25 into 1/4, that is 104, that means 1/16, so 1.0696. Now 0.06, that is added with this 0.037. You just add 0.06. So, okay, the value is 0.43. Okay, the value is 0.43. So that means the half of the heterozygote that is declined after generation, okay, and it's 1/4 of this heterozygous frequency that is added with the homozygous frequency. Clear? So this is the inbreeding process, and there is another important formula is that after Fn generation, what is the value of the heterozygote frequency or heterozygous frequency? That is 1/2 to the power n. So in case of homozygote, 1 minus 1/2 to the power n by 2, this will be the value, and same value it's happening to the small a. So we have to prove that if the value n value that becomes 2, what is the value of the homozygote frequency? Okay, we have to check this one. Okay, so we just take n equals to 1, and now we just putting the value 1/2 n. No, the value becomes 2. We have to take the value 2. So in case of heterozygote frequency, 2 square, that means 1/4, and homozygote frequency is what? 2 to the power 2/2. That means 1 minus 1/4/2. So that will be 4 minus 1/2 and 3/4 into 1/2. That will be 3/8, or maybe the value will be 0.38, something like that. So if we know the value of n, so you can easily calculate the value of the homozygote frequency and the heterozygote frequency. So this is the inbreeding type where the if the inbreeding occurring in any population, that means here the allele frequency that remains same, but homozygote frequency and the heterozygous frequency that will be changed. Okay, so here how to calculate the inbreeding coefficient, that is the short form I have written here, IC. So here we have to calculate this inbreeding frequency by this formula, 2 small p small q minus h by 2 pq, or 1 minus h by 2 pq, small p small q. So here 2 small p q, small q, that is what? That is the expected heterozygote frequency. Okay, and it is based on the Hardy-Weinberg principle. And h is h value, that is the actual heterozygote frequency. So one, that is the expected heterozygote frequency, and another you can say that observed or actual heterozygote frequency. Okay, so f value that may be belong to between 0 to 1. Okay, its value always remain between the 0 to 1. So if the value of the f that will be 0, then what is happening? That means no decrease in the heterozygotes. Okay, no decrease in the heterozygote. That means inbreeding is not occurring here. Okay, and if f value is 1, that means the completely inbreeding process is occurring here. Okay, that means no heterozygotes, only homozygotes will be seen. So in that way we can understand if in a population there is inbreeding is occurring or not by calculating this f value or the inbreeding coefficient value. Okay, so f value is when 0, that means inbreeding is not occurring in the population, but f value is 1, that means completely inbreeding process occurring in that situation. So this is the actual relation between the Hardy-Weinberg principle, not relation you can say that if inbreeding is occurring in that situation, what will be the condition according to Hardy-Weinberg principles on the analytic frequencies and the genotypic frequencies. Okay, so analytic frequencies remain always constant. There is no change. It will be always constant. If there is the two alleles, so that will remain continuously if in the homozygote form or in the heterozygote form. But what will the changing is seen, that is the genotypic frequencies. If inbreeding occurring, that means the heterozygote frequencies that is declined completely and try to decline, okay, and at last it will be 0. So in that situation, homozygote frequency that will increase, okay, continuously, generation after generation, the homozygote frequency that will increase, and at last suppose F5 generation or Fn generation, you can see that the actual heterozygote frequency is not there, but homozygote frequency is there. So what is happening in that situation? You can say that the heterozygote, due to the heterozygote frequencies, that means new feature or the variation, you can say, that will develop. Okay, so if heterozygote frequency is not there, so that means the variation or new character that will absent. Okay, so this is the actual situation that is happening in breeding. Okay, next we will learn about the effect of inbreeding. I just explained here briefly that what will happen, but also according to textbook, what will happening in the or the effect of the inbreeding in the environment, that will we have to learn. Okay. Okay, so actual effect is what is happening due to the inbreeding. The first one I said already or told that number of hybrid vigor or the variation that is decreased. Okay. Second point, that is very important point, not second point, this is a very important point. Here the chance of, we all know that two types of alleles are there. One is the dominant allele and another is the recessive allele. So here what will happen in inbreeding process, that the number of recessive alleles, they have the chance to enter or to form their individuals. Okay, so in that situation what will happen, that number of individuals that containing the recessive alleles, these will form or they generate. Okay, so in that situation some alleles which are harmful, recessive allele which are harmful, but due to the presence of the dominant allele or the heterozygotes, they were suppressed. But due to the inbreeding process, so there may be chance a harmful recessive allele that were totally suppressed by the dominant allele and the heterozygote, obviously. So there a chance will arise that these harmful allele weak individuals they can develop. Okay. So these are the actual result of inbreeding, or how it is affected or how its effect on a population. So these are the actual effect. Okay, so I think you totally understood about this topic. Next topic, it's that about inbreeding obviously, but this is the how to calculate the inbreeding coefficient from the pedigree analysis. I will explain in my next video. Okay, so obviously you just actually I am very busy in another work also, so I have less time to make the video and upload in proper time. So if you are all interested about this channel, so must you subscribe this channel and press the bell icon for getting the notifications when I upload the videos. Okay, and obviously share this channel with your friends if this is helpful to you. Okay, thank you.